Color coding of resistors. Resistor is the integral part of any electronic circuit. The value calculation of the resistance can be useful for an electronic hobbyist, for a science student, and for an undergraduate engineer. If this is the case with you, then this video is going to be very important for you. Need of color coding. The size of the resistance in any electronic circuit is so small that we cannot write the value of the resistance over itself. That's why we need color coding. This is how typically a resistance looks like in the electronic circuit. It has different color bands, and in these colored bands the information of the value of the resistance is encoded. Let's have a look how a carbon resistor looks like internally. There are two metal leads left and right side of the resistor which are used to connect the resistor in the circuit. There is a carbon film spiraled over a ceramic rod which gives the required resistance in the circuit. This whole arrangement is encapsulated in an insulated coating so that it becomes opaque from outside. This is the view of a resistor in which carbon decomposition is filled to produce the required resistance, and over the insulating coating the different color bands are formed which specifies the value of the resistance. Let's understand the meaning of the different bands in the resistors. Have a look over 4-band resistor. There are the 4 bands. First band is brown in color, which gives the first digit of the value of resistance. The second band gives the second digit of the value of the resistance, and the third band gives the multiplier. The fourth band looks aside with respect to the rest of the 3 bands, which is called tolerance band. The tolerance band gives the deviation in the value of the resistance, which is calculated by the first 3 bands. Now let's check the example of 5-band resistor. There are the 5 different color bands. The first band gives the first digit of the value of the resistance, the second band gives the second digit, and the third band gives the third digit of the value of the resistance, and the fourth band gives the multiplier unit. And the fifth band, which is aside with respect to the first 4 bands, which is called the tolerance band, give the deviation of the value which is calculated by the 4 bands. Now there are the 6-band resistors in which there is a 1 extra band with respect to the 5-band resistor, which is black in color in the rightmost side, which is called TCR, that is temperature coefficient of resistor. This band tells how the value of the resistance changes with respect to the temperature. Now let's have a look how the color coding is read. This is the table for the color coding. Any resistance can have these 10 different color bands starting from black, brown, red, orange, yellow, green, blue, violet, gray, white. These 10 bands has given the numeric value starting from 0 up to 9. When any color band is acting like as a digit, then the corresponding value is taken at the place of digit. When the band is acting like as a multiplier, then this corresponding value of the color is raised to the power 10. Now come to the tolerance band. If the tolerance band is gold in color, its value is taken plus minus 5%. If the tolerance band is silver in color, its value is taken as plus minus 10%. If there is no color in place of tolerance band, then by default the tolerance value is taken as plus minus 20%. Now here is a tip to remember the color and the corresponding values. The initial of every color has been taken and formed this sentence: B.B. Roy of Great Britain has very good wife, black, brown, red, orange, yellow, green, blue, violet, gray, and white. Let's have an example on how to calculate the value of the resistance by using color coding. Let's suppose this is a resistance given to us, which is a 4-band resistor. The first band is yellow, second one is violet, third is red, and fourth, which looks aside, is a tolerance band, which is gold in color. The yellow band has a value according to the color code table, that is 4. It shows the first digit in the value of the resistance. The violet color shows the second digit, and whose value according to the color coding table is 7. The third band is red in color, which is a multiplier. The value according to the red is 2, and because this is a multiplier, so the value will be raised 10 to the power. So the value of the resistance comes out to be 47 into 10 to the power 2, which is 4700. Now come to the tolerance band. The tolerance band, which is gold in color, and according to this tolerance band, we should do plus minus 5% in the value of the resistance. So the net value of the resistance comes out to be 4700 and plus minus 5%. Let's have a look at a few more examples. This is a 4-band resistor. It has one brown, then red, then brown, and then a gold tolerance band. So the first digit will be given by the brown, that is 1. The second digit will be given by the red, that is 2. And the third one, which is a multiplier band, it gives 10 to the power brown. Brown is 1, so this is 10 to the power 1. So 1, 2 into 10 to the power 1. And the tolerance is plus minus 5%. So it should be 120 ohms plus minus 5%. Let's have a look. Another resistor. This is a 4-band resistor. The first one is brown, the second is black, and third one is red, and fourth one is gold, which is a tolerance band. So first gives 1, the second one, which is black, gives 0, and the red gives 10 to the power, that is 10 to the power 2 according to the red color. So it comes out to be 10 into 10 to the power 2. So this comes out to be 1000 and plus minus 5% according to the value of the tolerance. Here are few more examples related to the color coding of 4-band resistors, which is 560 kilo ohm in value, and the 5-band resistor, which is 237 ohms in value. You can try it yourself. It's a blue, red, brown, and gold. Corresponding to the blue color band, the value is 6. Corresponding to red, the value is 2. And the brown is a multiplier, which has value 1, so it's 10 to the power 1. And gold band has a tolerance value of 5%. So net value of the resistance comes out to be 620 plus minus 5%. This one has 3 bands and there is no tolerance band. That's why the value of the tolerance will come out to be plus minus 20%. The first one is red, whose value will be 2. The black will have a value 0, and the brown will have a value, which is a multiplier, will have a value 10 to the power 1. So net value comes out to be 200 plus minus 20%. Similarly, you can try out more examples on color coding. Till then, thanks.